techniques. Beginning with techniques, we start off with your power rule, where we have y equals to fx to the power of n. Derivative is simply bring down the power to the front, reduce the power by 1, differentiate inside. Next up, trigonometry. We have only the three trigonometries that we need to know: sine fx, cosine fx, and tangent fx. Derivatives are simply f prime cosine fx, f prime minus sine fx. As you can tell, sine and cosine are relatively similar. For tangent fx, is simply f prime x secant square fx. Moving on to exponentials, we have y equals a power of fx and e to the power of fx. Derivatives are quite similar as well. Ln a f prime x a power of fx, and for e fx is simply f prime x e to the power of fx. Logarithm, very similar to exponentials as well. Y equals to log a fx or ln fx. Your derivatives are basically 1 over ln a, f prime over fx, and similarly just f prime x over fx. Moving on to our rules, we start off with quotient rule, where we have y equals to u over v. Derivative is simply u prime v minus, because it is quotient, so u prime v minus v prime u over v square. Product rule, so it becomes plus, right? So we have y equals to u times v. Derivative is simply u prime v plus v prime u. We finally have application, and we start off with normals and tangents. To find the equation of the normals and tangents, we have to use equation of a straight line. And the general form is given by y minus y0 equals to m bracket x minus x0, where x0, y0 is any point that lies on the line, and the m is the gradient of the line. Gradient of a tangent is dy dx at any particular point x. Same thing for normal, just that it's given by minus d1 over dy dx equals to minus dx dy. Moving on to rate of change, well, to give you some examples, dy dt, dx dt, dv dr, and dA dr. For any first derivative, dy dt for example equals to 1 over dt dy, but any further derivative such as d2y dx2 is not 1 over dx2 d2y, nor is it 1 over d2x dy2. dy dx equals to dy dt times dt dx equals to dy dt divided by dx dt as your connected rate of change. Lastly, we have stationary point, and we just need to equate dy dx equals to 0. There are only three types of stationary point: your local maximum or local minimum. They are local because they may not be the actual maximum or minimum point of the graph. Lastly, we have the stationary point of inflection. To test the nature of the stationary point, we have two types of tests, the first being the first derivative test known as the sign test. First, you draw the table starting with x, and with a minus, a plus, where a minus basically a value slightly less than a, and a plus being a value slightly more than a. A basically gives the value where dy ds equals to 0. You just need one outcome. I'm showing you all four outcomes, and then you just finally draw the shape of the graph. If the n shape is a maximum, if it's the two shapes as you're seeing right here is an inflection point, if it's a u shape, it is a minimum point. Alternatively, you can use the second derivative test, where you calculate d2y dx2 and plug in the x value. If it's less than 0, it's a maximum, more than 0 is a minimum. If it's equal to 0, well, you don't know.